This lesson is going to introduce the subject of hydronic controls, the devices we need to operate a boiler safely and efficiently. A reminder, for more information on this subject, including technical literature and other reference material, check out our website and use the literature search feature. This module is all about aquastat controllers. They're controls that monitor boiler water temperature and either start or stop a burner or circulator. This lesson is just about controls and not about system plumbing. A typical hydronic heating system consists of a boiler, a distribution system, some kind of radiation, and the controls to make it all work together properly. A simple system might have a single heating loop with several radiators all in series. Many times, the radiation in a hydronic heating system is zoned to meet the varying heating requirements in different parts of the house. Each zone is individually controlled by a thermostat and a zone valve. Zoning can also be accomplished by controlling separate circulators for each zone. There are three basic control jobs to do on a boiler. First, it needs to operate the burner safely when we need heat. So the burner control is designed to provide safe start and safe run cycles. Then we need to control the water temperature for both comfort and safety. So this means that we have a high limit to shut off the burner and a low limit to shut off the circulator. And finally, we need to control the circulation of water throughout the home or building. The thermostat turns the circulator on and off on each call for heat, all with the ultimate objective of maintaining a comfortable space temperature. There are two common fuel sources used for boilers, either gas or oil. Additional lessons in this series cover in detail these combustion burner systems. Now, let's look at the device that senses water temperature in the boiler, the aquastat controller. This is a single-function aquastat controller. It has a sensor bulb and capillary tube that drives a single-pole, single-throw electrical switch. It opens its contact when the water temperature rises to the set point we've selected on this dial. This stops the burner. The switch closes when the water temperature drops past the set point and through the differential. Some controls have an adjustable differential. Working as a high limit, this control opens its contacts on a temperature rise. So that means it closes its contacts on a temperature fall. So sometimes you may see it used as a low limit, where it brings the burner on to maintain some minimum water temperature for a tankless domestic water heater. This control, an L4008, is electrically and functionally the same, except that it has a 5.5-foot capillary connecting the sensor and the switch. This allows it to be mounted somewhere else on the boiler or even remotely on a panel. By using a single-pole double-throw switch, we increase the control's versatility. One contact opens on a temperature rise and one closes on a temperature rise. Some applications, such as a combined low limit and circulator control, utilize this capability. For a high limit, R2B opens on a temperature rise to set point. For a low limit, R2B closes on a temperature fall. And finally, as a circulator control, R2W opens on temperature fall to prevent circulator operation. Some specific models of the controllers we've looked at so far have adjustable differential. Others have fixed differential. Imagine how a high limit works. As the water temperature rises to the set point, the contacts open and the burner stops. As the water cools off, the switch remakes at some point below the set point. The difference is the differential. This remake point can be adjusted to occur between 5 and 30 degrees below the set point. Starting long ago, the trend has been to combine more control functions into the same package or case. This is an aquastat relay that incorporates the aquastat control, a relay to switch the burner and circulator, and a transformer to provide power for the thermostat circuit. It also has electrical terminals, so it can be the central wiring point for the entire boiler. In a typical boiler application, the aquastat relay controls the burner and the circulator. It monitors the boiler water temperature with a remote bulb sensor and watches for a call for heat from the thermostat. The next type of boiler control to consider is the triple aquastat relay, like this L8124. It gets used on boilers that not only do space heating, but also provide domestic hot water by the use of a tankless heater. In order to do this, an additional control function must be added, that of low limit. There are different models of the L8124 designed for gas and oil burners with line, low, or millivoltage control. Here's what it looks like. It has a transformer to power the control circuit, a relay to switch the circulator and burner, and all the terminals needed to wire it up. What's different is that the aquastat has got a couple more dials. One sets the low limit and the other sets the low limit differential. The high limit differential is fixed at 10 degrees. When the boiler water temperature gets below the low limit setting, the burner is brought on so the boiler stays hot enough to supply domestic hot water. At the same time, the circulator is prevented from running, so if necessary, the entire output of the boiler can go to making domestic hot water. The internal transformer in the L8124 can power 2 zone valves and thermostats. If more zones are used, an additional transformer will be required. Check the power requirements of the zone valves to determine how much 24-volt power is needed. This L7224U is the microelectronic version of the triple aquastat relay, designed for use on oil-fired burners. It's been specially designed to replace many other aquastat relays and controllers. The U for universal in the model number is the tip-off that this control is something special for servicing technicians. It replaces both earlier electromechanical devices as well as newer microelectronic aquastat controllers. Let me show you some of its features. These push buttons are how we adjust the settings. First, pushing all 3 buttons simultaneously for 3 seconds gets us into the setting mode. Then, the up and down buttons change the values of the settings we've selected with the I button, high or low limits, and the differential settings for each. This display shows what we're doing and also reads out operating status. In normal operation, it tells us the boiler water temperature. These LEDs show how the system is operating. One to tell us the thermostat is calling for heat, one to show the burner is energized, and one for circulator operation. This transformer powers the low voltage thermostat circuit, which is protected by this 1 amp fuse. All of the line voltage circuits hook up to this terminal strip. That includes the line voltage power input, outputs to the switch circulator and burner, plus connections to zone relays. Here's the sensor. It's electronic and plugs into the control right here. It's available in different lengths depending on how far it has to run to the boiler well. The control is always monitoring the sensor, both to make sure the sensor itself is okay and to very accurately measure the water temperature. The L7224 can operate with 2 different types of thermostats. A standard 2-wire low-voltage thermostat connects to the familiar TT terminals. It can also work with an Envirocom control system, terminals 1, 2, and 3 right here. Envirocom is a low-cost 3-wire communication protocol that allows different devices, such as Envirocom communicating thermostats, aquastats, and oil primaries, to connect and share information. With Envirocom, it's possible to get information on the whole system by plugging in a tester like this Quick Look 72 to the data port on any one of the controls. There are single-function aquastat controllers, such as this L6006, that have a sensor and a single switch. Then there are multifunction controllers, like the L6081, that have a sensor and 2 switches so it can operate different circuits at different temperatures. By combining an aquastat controller with a relay and a transformer, we get an aquastat relay that can be the whole control system for a boiler. The L8148 is an example of an electromechanical aquastat relay. A triple aquastat relay combines a multifunction aquastat controller with a relay and transformer and gets used on boilers that have a tankless heater for domestic hot water. L8124 is the electromechanical model that's been used for years, and L7224 is the new microelectronic version. Thanks for viewing this Honeywell Training on Demand program today. Printed reference material is available for this lesson. And remember, Honeywell has a hotline where you can get technical assistance on tough troubleshooting problems. To continue your studies on hydronic heating controls, we have 2 more lessons you should consider viewing: hydronic heating distribution and outdoor temperature compensation.